Okay, right here where it says convert each equation from rectangular to polar form. So what that means is if you have a parabola, y is equal to x squared, if you had a polar graph, what does that same equation translate to in polar form where you have r's and thetas involved? All right, so this is what you need to know. You know that x is the same as our cosine, y is the same as r sine. You also know that r is equal to x squared plus y squared, or sorry, r squared is equal to that. The square root is r is equal to the square root of x squared plus y squared. There we go. And theta is equal to inverse tangent of y over x. Those are the facts. So this says convert each equation from rectangular to polar. Well, it gives us a y. That y is r sine theta. X squared is r cosine times r cosine theta, because this is x times x. Well, remember, when you're multiplying polar, it's radius times radius, so r squared. And then when you multiply cosine times cosine, it's cosine squared when the thetas are the same. All right, so that's what we did here. I converted y to r sine. I converted x squared to r squared cosine squared. Then I want to get the r by itself. So what I did on the right side, I divided both sides by cosine squared. And then because I knew I wanted to move the r's, I divided both sides by r. So r squared divided by r is r. And then when I divided the other side by cosine squared, I just rewrote it as cosine times cosine. So it's sine over cosine times 1 over cosine. Well, sine over cosine is tangent, and 1 over cosine is secant. That's it. Y is equal to x squared is the same as r is equal to tangent theta secant theta. So guess what? I'm guessing that if x is equal to y squared, r would equal cotangent theta cosecant theta. All right, let's look if there's another one real quick. Oh, I'll pause this. Okay, the ones where you have a circle, ellipse, hyperbola, a little bit more difficult, but just pay attention to the details, and I'll go ahead and try to take this kind of slow. So we have x minus 1 squared plus y minus 3 squared is equal to 10. So that could be converted right there to r cosine, but then you've got it in this binomial and you have to square it. This could also be r sine. So what I recommend you do first is expand this. We remember when you have a binomial squared, it's the first thing squared, it's the second thing, it's 2 times the first times the second, and then you square the second thing. So it's x squared minus 2x plus 1. That's what I did here. And same with the y minus 3 squared. It would be y squared plus 2 times y times negative 3. Negative 3 times 2 is negative 6. and then negative 3 squared, which is what I did here. And then notice the plus 1, the plus 9 cancel out this 10 over there. So this side is now 0. And now we have, we have an x squared plus y squared. So we're going to put those next to each other because x squared plus y squared we can rewrite as r squared. Well, that leaves this negative 2x and negative 2y. So all I did next was add 2x and add 2y to both sides. And that's what I did here. And now look at, we can rewrite x as r cosine. We can write y as r sine. We're really close. But this is r squared. So we're going to divide an r by each side. Now that r cancels and that r cancels and one of those cancel. So that leaves r 2 cosine theta plus 6 sine theta. And that is the same, that produces the same circle as x minus 1 squared plus y minus 3 squared equals 10. If you put both of those in Desmos, they would be the exact same graph, but one would be on the polar graph and one would be on the xy plane. And we did the same one. Those are both circles. All right, let's come down here and see if there is. Okay, now we're, okay, I'll do a different video on this.